Hello everyone, I am Sanjar Abdurrahimov, who is a senior lecturer at the Department of Material Science, Tashkent State Technical University. The name of my scientific research is obtaining construction materials by recycling waste from metallurgical plants. Waste is based on iron dross. Everyone knows that most metal processing is carried out under heating. In this process, a significant amount of steel is oxidized and gives off dross. All industrialized states have this dross problem. How to recycle this dross and get some design. Now we are going to discuss scientific solution to this problem. The object of the research is the dross, which is the waste of the metal forming manufacture under pressure. For example, forging or rolling, etc. By reducing these oxides, obtaining construction materials and obtaining used in different filters. In the future, we want to produce new construction materials based on reduced iron powders or reduced distrust. Research subject is development of a technology for obtaining a low-load construction based on the reduced iron powder. We want to produce that constructions, designs. For example, these constructions will be all seal, gasket, collar, screw, stuffing box, etc. In Uzbekistan, this problem has been researched for several years and has most of the achievements. It's always dresses, iron oxides. The main method for processing this dross is reduction with hydrogen furnace. Here is the operating principle of a hydrogen furnace. You can see here the main parts of the hydrogen furnace. There is hydrogen supply, cooling system, muffle, insulation material, tungsten spray for heating, heat protection, and hydrogen torch. The boats are loaded with iron dross. Leaving the furnace, they become pure, reduced with iron powders. You can see. Replaying. Loaded and reduced with iron powders. Here, pure iron powders. This is morphology grain powders. The top shows the structure of the powder obtained by the Vega method. Vega method, this is vacuum induction gas atomization. These powders have a density almost theoretical to iron. However, the density obtained by the method of hydrogen reduction has these powders has a density almost 2 times less than the theoretical one. These powders is high porous. Application highly porous materials can be divided into the following groups. High porous materials. First group is filters, second group coolers, next group catalysts, lightly loaded powders, and groups insulators. Filters are most widely used. They are used to filter water, aerosols, greases, solvents, liquid and gaseous fuels, liquid gases and cryogen technology, fermentation products in the chemical industry, and nuclear power, etc. Here is, you can see, Prince filtration. It's a cylindrical filter element, and you can see filtration process. Powder permeable materials. Permeable materials obtained by powder metallurgy methods are also widely used in technology as filters, dispersants, dampers, flame extinguishing, and cooling elements of machines and mechanisms. During the pressing of powder materials, a porous space is formed, a channel connecting two sides of the material. In addition, the channels connected to each other form a porous mesh capable of filter liquid or gases. You can see here pore channel and powder particles and filtration process. You can see. Progress is our scientific research is within the framework of this task. Our scientists, Professor Karim Shair Akhralovich and Associate Professor Shakir Shratmusevich, conducted a number of applied research, developed and implemented filters used in the oil and gas industry on the basis of regenerated iron powders. There is filters already produced porous materials in our country. We have produced of a number of types of filters from porous powders and high porosity catalysts and some types of insulators. Now we need to add a new type of products, small sized parts used in light loaded plumbing and other anti-corrosion constructions. Below you can show a number of experiments that we have already carried out in this direction. It's our laboratory equipment is hot press and equipment SPS, spark plasma sintering. Our researches and experiments will be here. It's a structure our same microstructure our samples, and you can see that optical microstructure our samples. If you notice, each grain of the powder has porosity. Every powder has porosity. This makes it difficult to obtain a dense and durable material. We tried several methods lowering the amount of porosity of the powder. You can see here porosity is small. For example, planetary milling, ball milling, and etc. It's our results diagrams, dependence of the density of the pressure and the content of iron nanopowder, and diagram dependence of sample density on gamma logical sintering temperature and iron nanopowder content. You can see here 100% nanopowder has high density and small 4% has sample has the nanopowders has density is small. Its diagram is dependence of the sample hardness on sintering temperature and iron powders. Its diagram its dependence of the properties of sintering samples at gamma local temperature. And here our and Brenner emitted Taylor diagram. Everyone knows that what it is. The reason for this can be explained by the increase in the total surface. And conclusions. Our I've finished it. I would like to share all this with you. If anyone has any questions, I will be happy to answer them. Thank you for attention.